you for attending tonight. So yes, I'm going to go through the Pardo Gold Project. Um, Basically from when we discovered it to where we are now, which is in a resource delineation phase. Let's go. So before we get going, I'll just give you a little background on Inventus. We have two projects just east of Sudbury. Some investment highlights about us were we have a strong exposure to the rising gold price. We have an advanced gold project. It's flat lying near surface mineralization. We're located in a tier one jurisdiction, really close to Sudbury, which has established infrastructure. And our Pardo project could be a low capital, quick startup surface mining operation. And we also have a advanced exploration agreement with Temagami First Nation on the project. So here we can see my mouse. Um, the Pardo project. So we're 65 kilometers east of Sudbury. It's a 163 square kilometer land package, 100% held by Inventus, and it's considered an advanced gold project. And as I mentioned, it's got near surface flatline gold mineralization, which is what we're after. And we think it's got quick and cost effective resource development potential, which I'll get into, and potentially quick startup and low capital surface mining. Our other project, Sudbury 2.0, but I'm not here to talk about that today. So we're not your typical Ontario gold project. Um, we're targeting a paleoplacer, which is, last time I checked, we're the only ones in North America to be doing something like that. Um, we are in a great location, have year-round access to the project, and because of the access, we have there's potential for offsite toll milling, and that's kind of why I say that it could be a quick startup operation. The mineralization is flat, it's shallow, and it occurs at surface to 50 meters deep. And it's it's also got no arsenic, antimony, mercury, bismuth, or lead, so no penalty metals, which we've learned from our bulk sampling operations. And it's a advanced de-risked operation because we have 240 holes in it. We've outlined an exploration potential of 16.8 million tons, and we're in the resource definition stage trying to convert those to ounces, or that tonnage with a grade to ounces. Um, we have a 50,000 ton bulk sampling permit, and we've taken 5,000 tons of that. With two bulk samples, which we used for grade reconciliation. And we've shown that we have great metallurgy with over 90% recoveries. So I'll start with why explore for paleoplacer gold. There can be very large deposits, continuous laterally over vast areas. They have predictable gold grades, and they have excellent metallurgical recoveries. So some world examples, we got the famous Witwatersrand Basin, which is the single largest deposit in the world. It's produced 1.5 billion ounces of gold compared to everything else. And then you got Tarkwa in Ghana, Africa. It's produced 35 million ounces. You've got Jacobina in Brazil, which has produced 3.9 million ounces. I think still growing. And then some smaller ones that don't really have any mining, but they have resources are Castillo de Sonos in Brazil. It's got a resource of 2.5 million ounces. And then Beaton's Creek in Australia, which has got about 1 million ounces. So now getting back to Pardo, the history. So we've put in about 511 holes throughout the exploration that we've done on the project. And with that, we've identified 5 large areas of mineralization at surface. and we've done some bulk sampling to verify the gold grade. So all that work has led to us identifying a 2 meter thick gold bearing conglomerate lens. And it's got, from the modeling, it's about 16.8 million tons. The problem is we don't know the gold grade of it just yet, and that's what I'll get into and what we've kind of figured out over time. But we think it could be around 2.5 to 3.5 grams. And yeah, we've done two bulk samples, 1,000 tons returned 4.2 grams, and 5,000 tons returned 3.4 grams. So the early days, we optioned this property in 2009, and the drill campaign of that year, we intersected this nugget, and we didn't know what was going on. We didn't know what was like what conglomerate layer was hosting it. So we thought it was everywhere, and we went in, we did a property-wide drilling campaign in 2010, 2011. And that was done with your standard like NQ core. And then we coupled that with property-wide geological mapping. And we did not understand the stratigraphy at the time, which was very important for paleoplasters. And then later on, we discovered that the gold-bearing conglomerate lenses are actually slightly radioactive, and that's what's leading us to the right conglomerate layer, and things started changing from there. So we had a sort of the breakthrough phase, which was understanding the stratigraphy, and that was because we put so many holes in it, we knew we started figuring out that there was different formations, there was different members within each formation, and there was different conglomerate layers within each of those members. And that helped us, along with knowing what was radioactive and gold bearing, to figure out which conglomerate reefs contain the gold. So here's a map that we identified. The orange here, the yellowy orange color, that is the Mississauga conglomerate, and that's what hosts our gold bearing conglomerate unit. And making us like a north-south section through that. So we're going from our proximal sedimentary environment to our distal. And in the proximal area, um, there we go. Can you guys see that?
Yeah.
So in the proximal area, you start seeing larger clasts in the conglomerate, and in the distal stuff, you get just small pebbles. And from that larger drill program that was all over the property, we identified this, that you're getting there's a basal boulder unit, and then it fans out into like small quartz pebble conglomerates. And another thing we noticed was there's this lower unit called the Matinenda Formation. That's the same formation in Alley Lake that hosts the uranium deposit. We were noticing that when our boulder conglomerate actually truncates and erodes that, it was reworking some of the gold, the lower grade gold in that, and we were getting higher grade where it had truncated and reworked the gold from the Matinenda Formation. So once we identified which conglomerate reef was hosting the gold, we were able to use the drilling to figure out where that lens projected to surface. And then that led to trenching and channel sampling through the reef. And when we started channel sampling the reef, we figured out that things got a high variability gold grade because we have holes in it, which are telling us that it's running 2 meters, a half a gram, and you put a channel through the reef and you're getting grades up to 20, like 3 to 20 grams, and it's spiky all through it. And this image here is just showing, so we got one of our bulk sample sites there, and this red dash line is where the far side of the picture is where the boulder conglomerate sits undercover, and the red dashed line is where it projects the surface. And you're on a erosional area, so that's why it's so irregular. But that told us that we need to start bulk sampling this thing to figure out if we can trust our drill results or not. So I will jump into sort of the system that these deposit in. And here you have like a braided river system. So that's essentially what deposited the gold at Pardo 2.3 billion years ago. And when we, from our drilling, we have some sections through here. We've figured out this thing's continuous laterally over hundreds of meters. And then you can get gold concentrated in higher grade channels, and it's kind of similar to like or vein hosted ore chutes. So it has some similarities to a load gold orogenic system in that sense, but a little different because it's paleoplacer. And then we also noticed that there's structural offsets of it, so that we have block faulting where it's offset by up to 20 to 30 meters. And this kind of just gives you an idea. We're looking sections through here, and the color coding is the grade of the reef and its position below the surface. And then here's another one showing what it looks like on surface. Um, there's a scale of a meter there, and this just gives you an idea of some of the grades you can get. So 3.5 meters of 9.8 grams, including 0.7 of 47 grams. So potentially that is a higher grade channel area. And then here you got 2.1 meters of 3.3, including half meter 9.8. And then where it projects to surface on the east side, that's where we took our bulk sample from and got 4.2 grams in 1,000 tons. So on to the bulk sampling trials. The first one we did was at Trench 1. We did it in 2018. So we extracted 1,000 tons. We sent it to the McEwen Mining Black Fox mill. And the predicted grade of it from the drilling that we did, we used HQ core, which is the size of like an orange in diameter. And we did whole core sampling. So we sent the whole core to the lab, and the predicted block model of that drilling was 1.55 grams per ton. We took 1,000 tons, milled it, and we got 4.2. So we thought, oh my God, we're going to drill this thing and completely understate the grade. So we thought, let's do a bigger one, and maybe more holes can average out the predicted grade. So we did the 007 zone, which is pictured here. We took so that the trench one bulk sample had 11 holes in it. The at 5 meter centers, in the 007 bulk sample had 28 holes at 5 meter centers. And at that, we the predicted block model of that was 3.3 grams, and the mill grade was 3.4 grams. So a lot closer. So we thought, okay, we're on something. This larger diameter core can tell us the grade. So at that point, we spoke to Snowden Optero Engineering, and they had just done a 43101 resource on the Beaton's Creek paleoplacer in Australia. So we thought they'd be a good group to approach because they have some experience with this thing. And I'll skip the part. They thought, yes, you should do diamond drill core instead of RC, because that other project had done RC, because you have better control on the contacts of your mineralization. And they came up with 15 meter spacing for indicated resources and 60 meters for inferred. And this points to our sampling challenges. So we got, here's an image of the boulder conglomerate. You can get boulders up to a meter in diameter in this thing, and it's only 2 meters thick on average. So I've actually done a lot of pebble counting on the class inside the unit, and its average is around 70% of the unit is class. So we know that the class don't contain any gold. The gold's in the matrix surrounding the class. So only 30% of your material is going to contain 100% of the gold. And coupled with that, have a gold clustering problem. So from the first hole we drilled in 2009, I did some X-ray scans on it when I was in Germany working on my PhD, and what we thought was a nugget was actually just the smearing of the gold on the face of the core. And when you saw an X-ray image into it in situ, it's actually just a bunch of fine-grained gold particles. So if you're getting clustering of fine-grained gold, it's acting similarly to as a nugget effect, essentially, right? So what we need is larger samples, and I think we had the recipe for that with what we're doing now. So what is the resource potential at Pardo? 240 holes have outlined the 16.8 million tons that I was talking about. And this is, oh, this is the outline of that 16.8 million tons. It could grow with additional drilling, but that's what we have right now. So we look at that and we say, okay, these conglomerate layers that are gold bearing aren't going to be everywhere, but um, so we're looking at like a conversion percent. If we can convert 50% of this area to a grade of 2.5 to 3.5, then we could potentially have somewhere around 750,000 ounces. So it kind of gets me excited, and um, it ultimately how much of this stuff is going to be around 2.5 to 3.5 grams, we don't know. And that's why we're doing our phase one resource drilling to figure out how many ounces we potentially have there, or the true grade of the rock to figure out how many ounces we got. So this is well, not ongoing in the sense we finished drilling this. We started this in mid-November. We call it our phase one resource drill program. So what we thought was a good use of capital was to target this conglomerate layer where it's from 15 meters to surface. So shallow holes, we can get a lot of them. So in December we drilled 80 shallow holes into this thing, which is the red circles here. Those are all of our new holes. And we've gone with photon assaying and doing full core sampling, taking lots of photos of the core to keep a good record of it. And results are coming soon, but we actually just I put out results this morning, so I'll share a little bit of that with you. And the whole point of this was to demonstrate the tonnage and average grade, show to everybody that there's surface mining potential here. And because it's so cheap, we can show the cost per ounce discovered is going to be quite low. So this whole program is roughly $500,000 and you get 80 holes. So yes, this morning I put out results for the first 28 holes, and it's looking good so far. It's demonstrating lateral continuity of the grade. The PQ core is smoothing out the highs and lows to what I think will be a tolerable level for resource estimation. And we're starting to generate blocks of rock that are around 3 grams per ton. And here's some photos of the core we just drilled in December and some of the grades we're getting. So 4.6 grams over 2.3 meters, and that included 21 grams over 4.6. 0.46 meters. Um, and it, yeah, you can read the rest of them there, but that's what it looks like in fresh core. So you're getting these, we call them buckshot pyrites. That was a term coined by the South Africans because they have similar pyrite in their ores, and I think all the paleoplasters have that. Um, and they attribute it to pyrite rolling down a river system and rounding and then depositing with the gold because it's also heavy like gold, right? So what's next? Phase two drill program. So if the rest of our results are similar to the first bit of drilling, we're going to try to do a phase two drill program and start probably drilling at wider centers and stepping out to the northwest and the southeast. And I think with about 5 to 7,000 meters of drilling, we potentially could get to the 20 to 30% conversion rate uh, of our exploration target. And this is yet to be determined, but I think the cost per ounce to find once we, if the grade holds up at 3, will be probably like less than $10 an ounce. Okay, it's great. We can define an ore body at 3 grams per ton. What's really interesting about that is you can open cut mine it, and surface mining is cheap, right? So 3 grams per ton close to surface should be doable. So here's an image of us extracting the 007 bulk sample, and essentially you just blast, pull it back, run it through a crusher, create a pile, and ship it off to the mill. Um, okay, what about the deeper parts? So anything below 15 meters, I think we're going to create too much waste. So we've put a lot of thought into how would you go after that, and we sort of did an internal engineering study on that. And we think it would make sense to do room and pillar mining. So it's got minimal development and high mine productivity because you're always in ore. There's no development. Um, Less surface disturbance, reclamation, and waste rock created, and you can use the waste rock as backfill. And another interesting thing about room pillar on a flat ore body is you can actually go straight for the higher grade channels. So, and there's no development to get into those higher grade areas. You can just follow it along. So project upside potential. There's discovering higher grade channels. There's extending the exploration target beyond 16.8 million tons. So this is that 16.8 million tons. The dark orange is our target rocks, and there's no reason to believe this doesn't continue. It's just we don't have uh, we haven't really focused on it because it's deeper, and we don't have as many drill holes in it to confirm that it's there yet. And then as you go south, you are getting to a more distal environment, and you could get stacking of gold-bearing reefs. And we've already seen that in some of our deep holes. So we know it's happening. It's just, can we find areas in the deeper parts where we, like our drill holes, we were seeing it sometimes 5 centimeters thick, and it was running about 10 grams. Um, and we were seeing it up to like half a meter and running 5 or 6 grams. So what we need to do in the south is basically do fence lines of holes east west and try to find areas where you're getting channels and it's thicker and it's actually has a mineable width. But we know it's gold bearing down there, and a lot of room for channels to sit in here where we don't have any drilling, and we could find stacking of those reefs. And then another interesting thing about Pardo is because of the large boulders in it, we've done some tests, and the stuff we could deploy ore sorting with it. It's got a lot of internal dilution, So some preliminary tests are quite positive, but we're at the point where you have to do um, like 1,000-ton trials of ore sorting and then measuring that. We're kind of over the sort of engineering phase of that, and that costs capital. And we thought our best capital was working on defining a resource first. So that concludes my presentation. If you have any questions, let me know. Do you know where River Valley is? Okay, so we're north up that Highway 805. We're about 25-minute drive north of River Valley. So on this map, the lighter yellow color is cover rocks. So you have to put holes through it to see if it is there or not there. We have one hole up here. We went through the cover rocks right into the Archean basement. So we know it's not there, but it's a pretty big area. So there's lots of potential for that, for it to be under the cover.
Just on that top started high. Do you have a mark or how do you start high?
Um, I think once we grid drill it, you're just gonna see you'll see higher grade areas, yeah. And there is some key visuals in the conglomerate layer. One thing that we do see is those buckshot pyrites that I was showing. So when you see them really, really fine and a lot of them, that's usually a great concentration plane of gold. And we've seen it in core sometimes you see maybe 4 or 5 centimeters and it's just loaded and there's a bunch of specks of visible gold all through it. And that's where you get those like 20 gram, 40 gram intercepts over half a meter or so.
When you go further to the south and you're getting into more of a distal environment, you're saying it's finer grained.
Mhm.
Wouldn't you expect that there'd be less gold in that, in that kind of a lower energy where the gold is dropped out more in this closer to the water?
Uh, Not necessarily. Like a lot of these, like for the Whit watershed, for example, that is their primary ore body is like small pebbles. I think a lot of gold got trapped in the proximal area where we're working because the boulders, once they stop, they create like eddies behind them.
Yeah.
Sort of like where those fish stop on rivers, right? So it's like a pressure drop, and I think we're getting gold collection behind the boulders, and that's why I think we're seeing the strong variability in the grade too. There should be, yeah, yeah, it can travel further, yeah, for sure.
You mentioned slightly activity.
Yeah.
Well, fine.
We find little specks of uraninite in the rock.
But is that associated?
It is, yeah, it can be.
So the question is more than likely this is a matrix,
The uranium?
you know, very,
Well, you're getting little specks of uraninite and it's heavy just like gold, right? So it falls out of suspension with the gold. That's why it collects together.
pretty brass. Let's say this, so
Yes, that was one of the elements that we looked at. But it was actually it was a density was kind of we weren't sure if it was gonna work. And then we coupled uh zircon and sulfur, and we tested that, and I was getting great recoveries. So it was basically capturing zircon grains and sulfide, and that was almost grabbing all the gold with it. But that's a slower sorting type, right? Than doing density.
I'm assuming you haven't something for where you have
We have a borehole scintillometer, but we've never deployed it in a regional sense to to sort of see areas where it's higher or not. We've kind of been going off visuals and grade, but it's something we probably will do in like a phase two. We get more personnel and a bigger budget to do additional resource drilling.
Thanks for sharing. I'm still very curious how you laid out your drill program. Start before you understood the strategic. How did you? How did you
Like I
know?
said, we had no plans. We kind of just blanketed everywhere. And because we did that and it was smaller diameter core, uh, gave us a good idea of the strategic. Like that's how we learned. It was we weren't focusing we thought it was everywhere and we didn't really know what conglomerate unit hosted the gold. So we kind of just looked at this area after it was mapped and just started putting holes everywhere. And that's you can kind of see those blue dots. We had them quite all over the place. And that's when we started to see, okay, there's a distal component to this. There's the Matnenda formation that's present in the north that it's been truncating and reworking.
So you're more like fencing, fence style level, right?
That's what we initially did, yeah.
Every 10 meters or.
No, I think we were doing 100 to 200 meter centers.
Yeah.
So we figured out like, oh, from that we figured, okay, there's block faulting here. We knew which way the blocks were dipping, and that helped us figure out, okay, if it's blocks dipping this way on this end, it should project to surface. And that's how we found some of these surface exposures that led us to channel sampling and realizing the high variability of gold grade in this thing.
What's the average depth of the exploration?
Uh, Primarily, most of our drilling is in the north part in here. So that occurs from surface to 50 meters deep. And then we have maybe, I want to say like 15 or 20 holes in the south where we put them down to 500 meters. And you're in the Mississauga the whole way and you see multiple stackings of small lenses of quartz pebble conglomerate and they all run. It's just we'd have to do fence drilling to see where there's a channel because you essentially you want to find something like that in the distal part. And if you put a hole here, you're going to hit probably a little lens. But if you hit one of the main channels, you could get something that's maybe a couple meters thick. So that'll be, we'll start at the north where it's nice and shallow. And if that works out, then we'll just keep moving south. Yeah. Which one running? Oh, the distal stuff. Some of our very high grades come from there. It's just got no width that we found so far. So you could get a pebble lens like 5 centimeters. It runs about 20 grams. It's just I don't think you'll ever mind that unless you get 50 or 100 grams because you have to take at least a couple meters, right? 2 meters. So that's what I was saying. If you can find a channelized area down there that's got a meter or two, um, then you're off to the races.
In the north, what's the average dip you have?
About 5 degrees. Each block slightly different.
Let's see if there's any questions online. You got 3.
Could you provide a base case target ounces for the MRE? I think I did. Oh, how do I work the?
Okay. So you need to go.
Oh, manually do it?
Yeah, but now it should be like 5 before.
So if we did the phase two, which is roughly around 6,000 meters of drilling, we think we can get in this 20% conversion rate which would put us, it's a larger footprint than what you're seeing here. And that would be a combined, you'd have to do quite a bit of inferred resource. So you'd be drilling at probably 60-meter centers, 30-meter centers, and maybe some 15-meter centers for indicated. But it would get us somewhere around, yeah, 300 to probably 300 to 400,000 ounces, something like that. Okay. I am relatively convinced this is exactly. Oh, is everyone reading that too? No, no. That's not really a question. I am relatively convinced this is exactly what was originally underlying Government Road and Kirkland Lake. Same conglomerate with flecks of gold. Large deposit nearby. Okay, I think that's it. Is it just this chat? Okay, so only 2 digital or Zoom questions. No, it's pretty low grade. So it's high enough you can see it with a scintillometer, but it's not high enough that it's a problem. And we had a real concern. So when we took our 5,000-ton bulk sample, we created a flotation con, and we were like, oh no, we're gonna collect all the uranium in this thing, and we got to get it melt down and get the gold out of it. So we did a bunch of tests, and we ended up sending it to the Horn smelter in Quebec, which has they have a lower threshold of what they tolerate there, and it was fine. It was under what the guidance was, so it's fine. I think I mentioned that early on, like we had very little penalty metals in this stuff.
Is that what they're doing? Just float? Is that the concentrated?
Gravity plus float. Oh, I kind of skipped over that slide, so I guess I'll give some time. So that 5,000 tons, 70% of the gold was in the gravity comp, which is pretty good. And then we had a 95% overall recovery. And then that's a picture of our flotation con in the bay. And then I took a little bit of gold out of one of the con bags and panned it, and it's nice fine grain gold. And we think for an on-site processing facility, I think we're gonna need something north of 300,000 ounces, but don't quote me on that. So we could ship it. It's just trucking adds up, right? So if you can prove up a big deposit that's worth putting in the capital to build a mill, then that would probably be the way to go. And then for offsite processing, there's some local things like potentially we could get something in Strathcona, but that'd be a bit of a challenge. There's the Fox Mill, McEwen Mining, it's 335 kilometers away. And then where we sent our 5,000 tons was Redstone Mill, just outside of Timmins.